Good evening, fifth graders. Tonight we're working with some three-dimensional shapes, so shapes that look 3D. We're finding the volumes of these shapes. We're going to find out how much we can put inside the shape. What is this three-dimensional shape? How big is it? What is it made up of? So that's what volume is. How do you label volume? This is really important. Well, let's just go over how do we label area. So if we're labeling area, right, it'd be inches squared, centimeters squared, meters squared, feet squared. That's area. Remember, to find the area, it's base times the height. Base times height, right? That's area. We've been doing the practice for that. Now with volume, we're actually going to be multiplying three numbers together to find the volume. Watch closely. This is how you label it. Inches cubed, centimeters cubed, meters cubed, feet cubed. This is what the formula for volume is. Volume equals big B times height. Now let's take a look here. Big B is different from the little b. The big B, this is what the big B represents. Big B equals the area of the base. And then you multiply it by height. So a three-dimensional shape will look like a building, look like a house, look like a cube. Let's take a look at some of these things. Here are three-dimensional shapes. So 3D, right? You can tell that you can kind of look all the way around it. So that formula I just went over, volume equals big B times the height. This big B represents the area of the base times the height times h. That's what it looks like. So this first shape, for example, we're going to be going 6 times 12, right? That's our big B. That's the base, so the bottom of the shape. Most of the time, the base is the bottom. If you can't see the bottom, more times than not, the top of the shape is going to be the same as the bottom, okay? How tall is it? Our height? Well, if this is 3 right here, this would be 3, this would be 3, this would be 3. So we're going to be multiplying this by 3. So how do we figure this out? Going 12 times 6, 12, 6, 72. Then we're going to go 72 times 3. We have a 6, 216. This shape right here has a volume of 216 inches cubed. It's not squared. Cubed, think three-dimensional shape for cubed. Let's take a look at this other problem here. This shape right here now has a base of 6 times 3 times a height of 12. Doesn't this shape right here kind of look just like this shape right here, but on another side of the base? Now keep in mind, the base can vary, right? But most of the time, or for all the times, let's just keep the base at the bottom. So we just flip this upside down. Will we have the same volume? Well, it seems like dimensions are the same. 6 times 3 is 18. Then we're going to go 18 times 12. 2 times 8 is 16. 2 times 1 is 2, plus 1 is 3. Place value holder, we have an 8, and we have a 1. Let's add these up. We have a 6. 8 plus 3 is 11. 216 inches cubed. One more over here. Base times big B, so we have 12 times 3 times the height, which is a 6. Once again, it's the same shape as before, but it's just flipped over again, right, on another side. 12 times 3 is 36. We're going to multiply that by 6. 6 times 6 is 36. 6 times 3 is 18, plus 3 is 216 inches cubed. Let's take a look at some more problems here. All right, we've got a rectangular prism here. Now you can't see the base, right? The base is on the bottom here. So that's where kids get tricked all the time. But take in mind, the bottom of the shape isn't the same as the top. Let's take a look at the top of the shape. Let's take a look at this rectangle up here. Okay? It's a three-dimensional rectangle. So if the rectangle looks like this, looks like it'd be a 2 here with the height would be 2, the length would be 4. So my formula that I have written down would be 2 times 4, which equals my big B, times my height. Let's see, where can I find the height on this? Looks like straight 1, 2, 3, 4. You see how tall it is right here? It's the height of 4 times 4. Well, if I figure this out, 2 times 4 is 8. Times 4 gives me 32. And right here, I have centimeters cubed. Now let's take a look. Does that make sense? Well, if one layer has 8, I have another layer here, another layer here, another layer here. Yeah, that makes sense. That would be 32. Let's keep going here. Here's another rectangular prism. Once again, I can't see the bottom. What I can see on the bottom, though, is I have a length of the bottom of 1, 2, 3, 4, 5, 6, 7, 8, 9. As you can see, it'd be the same 9 shapes right up here up top. So it's going to be 9 times 2. My height is 1, 2, 3. 9 times 2 is 18 times 3. 18 times 3, 24, 54. 54 centimeters cubed. Now, does that make sense? Let's take a look here. Well, if I have 9 here, that means I have 9 cubes here. I have 18 on this row, 18 on this row, 18 on this row. That would be 54. Next problem here. Okay, we have a little taller shape. Let's take a look at what this top layer is. Remember, this top layer is the same as my base. If the base is hard to see, I have 1, 2, 3, 4, 5. 5 times, it's like 2 again. But the same as down here. 1, 2, 3, 4, 5. And I have 2 here. 5 times 2, my height is 1, 2, 3, 4, 5, 6, 7 times 7. 5 times 2 is 10, times 7 is 70 centimeters cubed. Let's take a look. Does this make sense? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 on each layer. If I have 10 on each layer, if my area of the base is 10, so let's say this bottom layer is a 10, that means I have how many layers of that? 1, 2, 3, 4, 5, 6, 7. 7 layers of 10? Boom, that is correct. All right. Sometimes we need to find how much or how big a fish tank is, for example. Same concept here. Now we don't have the blocks. Now we're dealing with feet. Okay, that would be an enormous fish tank. Anyways, let's take a look here. What I want you to remember is three-dimensional shapes. Obviously, it's my best drawing there. Look just like that. Well, kind of like that at least. Anyways, you get my point, okay? Actually, it would look more like something like that. Anyways, the bottom of the shape is a rectangle. So we have a rectangle down here at the bottom of this shape, right? Kind of looks like that, something like that. I'm not the best drawer, kids. But if I can't see it down here, it'd be the same as up here, right? So if this is 2 feet right here, this would be 2 feet as well. If this is 14 feet, this would be 14 feet, and this would be 14 feet. The point I'm trying to get at, kids, is if I'm writing my formula, my big B would be 14 times 2, wouldn't it? My height, it's the same height that goes all the way around this shape, in the back there, would be 6. That's how I would find the volume of this shape. So what I do know is 14 times 2 is 28. I multiply that by the height, times 6. 8 times 6 is 48. 6 times 2 is 12, plus 4 is 16. 168 feet cubed is how big this fish tank is. Let's take a look at this shape. Same concept here. Let's see if I can draw a better example in the background there. That looks a little better. Still absolutely horrible. I apologize. But let's take a look. The bottom of this shape, wouldn't this base be the same as this top part? Well, if this is 7 right here, this has to be 7. This has to be 7. If this is 5, this has to be 5, this has to be 5. If this long shape is 12, this has to be 12, this has to be 12. Do you see where I'm going at here when you're dealing with these 3D shapes? So let's take a look. What would be the area of the base? It would be 7 times 12. It would be my big B. When I'm multiplying, it'd be my height, which is 5. 7 times 12. We have 1484. Then I'm going to multiply the area of this base times 5. 20. Equal size 40 plus 2 is 42. 420 centimeters cubed. Yes, you have to label everything correctly. Okay. Last one. Got a crazy looking shape like this one. This one's a little more challenging. Let's see if we can do it. Okay. First part, we have to break it apart. So let's say I've got this shape right here. And I've got a nice long rectangle right here. Then I've got another rectangle right here. I want you to try and press pause and see if you can figure this out, okay? But right now, the reason why I trace those is because those will be the same as my base. So if I can find out the dimensions of these shapes are right here, I'll be able to find the dimension of my base. Let's take a look right here. This first shape I drew right here has a base of 1, 2, 3, 4 times 1, 2, 3, 4. So this is 4 times 4, which equals 16. Okay. This right here is 1, 2, 3, 4. Then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my length is 12. So this would be 12 times 4, which equals 48. Okay. Then over here I have a 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And I have an 8 times 4, which is a 32. So the area of my base, kids, is going to be 16 plus 48, which is 1464. And I have to add this 32 to 64. Sorry, it's getting a little long, but I think it's important for you to be able to see how I work out a more challenging problem, because you will see these tomorrow. 4 plus 2 is 6. 6 plus 3 is 96. Now, we have the area of the base found, right? It's 96 is the area of my base. That is my big B. Now, with volume, it's big B times height. What's my height all the way around? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I have 4 layers of 96 is the point I'm trying to make. 4 times 6 is 24. 9 times 4 is 36, plus 2 is 38. 384 centimeters cubed. Once again, I probably made a mental mistake during this video, but I want to try and keep the video time to a minimum for you. But I thought it was important for me to show you this last problem. So tomorrow when you come into class, you're ready to be challenged and ready to be learning at your fullest potential. All right. Look forward to working in class tomorrow, kids. Hopefully this helped.